Welcome. So this is the video demonstration I'm creating for my project. So these are all the libraries that I have included, and this line we have written to create this chart folder in which we will be storing all our images. Then for the pre-processing, I have removed the age underscore group column because it is highly correlated with the age column. So we are reducing the redundancy in our dataset because it is actually derived from the age column. Then we are applying one-hot encoding for the categorical column and standard scale for the numerical column. This is all we are doing for the pre-processing part. Then we have trained a logistic regression model initially to get an idea of how our data is actually distributed by logistic regression, because it is a very interpretable model and we can easily get the idea of how the weights are assigned to each feature in our data. Then we are using this order bias method. In this function, we are using the fairlearn library to get two estimation, that is a demographical parity difference and equalized odd difference, to get an idea of how much bias is present in our data. So if their values are closer to 1, that means the data is highly biased, and closer to 0, that is the data is unbiased. So this is the function that we are used to get all the figures and charts that we will be storing in our folder. So these are all the SHAP features and that we have created from the dataset. Then we are converting the target column into numerical and applying all the pre-processing training portion. Then we are getting some SHAP. Then after that, we got the values. That is exactly one, that means the data is highly biased in the initial data set. And these NaN values over here indicate that there are no actually representative of them in these categories. That's why they are showing NaN. That means in this category there is no yes or no, uh, denied or no approved in the target column. So we are plotting them to get an idea. So here you can see that the non-binary representation is very less in the gender. Similarly, in the race, the white section clearly dominates for all the other races combined. Then in the employment type, there is a high, uh, there are very high values of full-time employment than any other. Then similarly, we can see for other columns also. There, the data present over here is highly skewed. So we will try to get an equalized data for our model to train, and on the similar hand, we will try to make the accuracy as good as possible by getting a very good trade between bias and variance. So this is the part that I have created to get an initial idea of how a model is working on the dataset. So logistic is getting an accuracy of 63%, and similarly, the XGBoost is getting an accuracy of 58%. Uh, when we have not oversampled our data, then after sampling using smooth on our data, we are getting these results. Uh, so the accuracy is almost the same, is 62 and 60%, but we are able to reduce the biasness from 1 to 0.42 and 0.41. And similarly for race, we have reduced it from 0.18 to 0.6, and similarly for the function. Then the final notebook I have created is this, by taking all the important part of all the processes that I have created. Then the loader loan underscore model.py file is the same as the final IPYNV file that I have created. When you will run this, you will get a submission file from the test folder. Then this is the readme I have created. I will add here the link of the video of this video also. Then the report we have created and the figures that we have created in this. You can get in the chart folder from the GitHub link I will provide it. Thank you.